Here they're saying that identify metal M in unknown metal carbon, yes, and then produce. Okay, procedure is carried out. You have this mass of impure with this reacting as nitric acid. Yes, so the excess nitric acid will react with this sodium is barium hydroxide. Okay, assume that the volumes were predictive. All right, the following reaction takes place, and they are saying that you have this plus this gives you that. Okay, define the term strong base. This is a definition. We usually talk about it, but please define it. Strong base basically it must be able to dissociate completely when it dissolves in water. Yes. So they are saying that the number of moles, calculate the number of moles of barium nitrate, barium hydroxide reacted with the nitric acid. So you have to use the excess, whereby this one is not that big deal. How do we calculate that? So in this case, we're gonna say that a number of moles of barium nitrate is gonna be equal to the number of moles of barium hydroxide that reacted with excess. So but here we know that we know that. So you can use first principles or you can use formula. Yes, concentration times volume, whereby number of moles is equal to concentration. You have the concentration, which is 0.15 times volume, which is 20 divided by 1000. So after that number of moles, let me check if I calculated it. Yes, I hope I calculated it. Yeah, it is equal to 0.003 moles. So that's how you can calculate the number of moles of that. And they're saying calculate the pH. The pH of solution after step 1. The pH of this solution after step 1 is basically determined by how much nitric acid was remaining. So in most cases, so this pH, because they said excess, so it means that we have to go for step number 1. Understand? Yes. But now we have to first compare the number of moles of barium nitrate, the number of moles of barium hydroxide compared to sulfuric nitric acid, because you know the number of moles of barium nitrate, barium hydroxide, then automatically we can find the number of moles. Okay, let's start by saying that mole ratio. Barium hydroxide to nitric acid. So barium hydroxide, barium is 1 and then nitric acid is 2. So what we're gonna do is we bring our barium hydroxide 0.03, yes, 2. So you have to multiply. It's gonna be 0.006. So this is the number of moles of nitric acid which are reacted with barium hydroxide. But now I need to find out the concentration of this in this 25 cubic centimeters. So I will say that concentration is equal to times volume is equal to number of moles. So we have the number of moles. We have 0.006 is equal to concentration, which is I don't know, times volume times volume, which is 25. Yes, because we want to know how much is in the 25, but this is not decimeter cubed divided by 1,000. So that now concentration is going to be equal to this divided by that. Yes. So this times that divided by 25. So we just reciprocate it. And then now when you calculate, you get almost concentration 0.24 molar or moles per decimeter cubed. If you write capital M, it is still fine. So now C, the concentration is that. Now you need to take note of that, of this, before you go for this concentration. If this number of moles, if this nitric acid was a diprotic acid, I would have multiplied it by 2. But because it is a monoprotic acid, one hydrogen will be equal to the number of the moles of nitric acid will be equal to the number of hydrogen which are being produced. Understand? If it was sulfuric acid, I would have multiplied it by 2, because one molecule gives you 2 atoms, 2 ions of hydrogen. Yes. So I'm clear there. So now, since it is monoprotic acid, everything is supposed to be flowing. Then the pH is equal to negative log of hydrogen concentration or hydrozonium ions. So now we know already the concentration as this. So pH is going to be equal to negative log of 0.24. Yes, and then the pH is supposed to be acidic, gives you 0.62. You can calculate and find out if it is the figure I've given is the perfect one. So yeah, guys, that's how it's supposed to be obtained when it came to that. See, yes. So it was not that very difficult if you knew how to interpret it. Now let's go to the next question, which is percentage purity. Okay, in percentage purity, base showed me who is the boss. Sorry, subscriber, sorry. It showed you who is the boss. So who is the boss? Tell me who is the boss. Is it you or is the base calculation? Sorry. Okay, let's go to so we are done with the pH, those 5 marks. Let's go to the percentage purity of this. Now we need to analyze something before you start doing any calculation. You need to first analyze and see exactly what happened. Yes. Okay. Now, they say that this is an impure with this mass, so it means that we're gonna use that mass. But they say that in that mass, only 85% of it is what is pure. Only 85% of it is what is pure. So it means that we have to find out how much number of moles are in that pure substance. All right. Now, number 2, they say that excess they reacted this with the nitric acid. Understand? But the excess nitric acid, you see, excess nitric acid was reacted with barium. But now we don't know how much we started with, how much reacted, and how much remained after reacting. So now we have to calculate all that so that we can score these 8 marks. So now, how much we started with, we can calculate. How much we used, we calculated it already. Then after that, we can subtract. When we subtract, then we can know how much was used. And then we can use that to compare, and then we find we can find the number of moles, and then after that we can find the mass. Did I say the mass? The molar mass in that regard. Let me just show you what I'm trying to say when it comes to this. Okay, let me start by saying that already now we know what is in excess. We calculated it. Did I rubbed it off? But we know what is in excess. So now what you're gonna start with is let's find out. So let's start with what is in here. How many number of moles are in here? Then we know how many moles which is here. Then after that we can subtract. Okay, say that 25 volume is equal to 25, and then concentration 0.4 moles, molar, let me just say molar, and then this one is cubic centimeters of what? Of nitric acid, nitric acid. Now we need to find out the number of moles of nitric acid which is in here. So we're gonna say number of moles is equal to C. We have different methods. You can use these generals, but also first principles is still also fine. Times volume. So number of moles here is gonna be equal to 0.4 times 25 divided by 1000. So number of moles here, when you do in the calculator, is gonna be 0.01. If you find an answer which is deviating a bit, please, it could be when I'm trying to press the calculator. Yeah, it could be, but the method remains the same. All right. So this is all the nitric acid which is in there, plus the excess, plus the one which reacted. Now let's find out what is in excess. Nitric acid excess. So nitric acid excess, we calculated it already, isn't it? By finding it here, isn't it? Yes, we calculated it already, and then we said that okay, let's do it. 20, still the same thing. Number of moles is equal to CV, whereby number of moles is gonna be 0.05 times 20 divided by 1000, so that I get to know remember it's supposed to be in decimeter cubed. Number of moles, this is the excess, the one which reacted with barium hydroxide, and this is the whole nitric acid. Yes, so the answer is going to be 0.003 moles. But these moles, these are the moles of barium hydroxide. Understand? But now you can use the mole ratio to find, because that's barium hydroxide. The mole ratio is 1 to 2. So it means that nitric acid is 2, while barium hydroxide is 1. So barium hydroxide is 1. So it means that if this is 0.003 for barium hydroxide, then nitric acid is going to be 2 of them, meaning that I have to say 0.003 times 2, which gives me 0.006. So these are the number of moles of nitric acid excess. Yes. So now once I get the number of moles of nitric acid in excess, now I can subtract this from this. So I'm going to say that number of moles of nitric acid used, because that's what we want. We want to know what is used, because the one which was used to react with this impure, this, so that yes, we know exactly. So now here I'm gonna have this is gonna be, let me see, 0.01 minus 0.006. You see, that is the number of moles. When you subtract, you must subtract it nicely, then 0.004 moles. So these are the number of moles of nitric acid used at the first run, the first instance. So now, since now I know the number of moles of nitric acid which got used, check. Now I know the number of moles of nitric acid which got used here. Now I can find the number of moles here, so that now I can use the number of moles is equal to mass over molar mass. Yes, so now since I know the number of moles which got used here, so now I can, yes, let's do the mole ratio again. Mole ratio is equal to nitric acid. Am I writing it? Nitric acid to M carbonate. Yeah, and there is something which you need to know here, that this M, because this is it must have a charge of 2, so that, remember, carbonate is like this, so this M must have a positive charge, so that this cancel, and then you form M carbonate. So it means that this element is supposed to be in group 2. Yeah, must be in what? In group 2. So anyway, this is that. So we got it. Okay, he said this is 2, and then this is 1. Am I right? Let's go back. Yes, it's 2, it's 1. Good. Now these are number of moles, so this is 0.004. Yes, so automatically this is going to be 0.004 divided by 2, which gives me to be 0.002. So these are the number of moles of this. So now once I get the number of moles of that, now I can find number of moles is equal to mass over molar mass. I can find it. Yes. How am I going to find it? Alright. Number of moles now I have as 0.002, yeah, is equal to mass. Do I know the mass? Yes, they said it here. They say that only 85% of the impure, so it automatically, we have to first calculate this out, and then we find out which one is impure. So if you look at this, because they say that 85%, so I have 0.198 0.198 times 85%. So this is gonna give me the mass of pure sample. You understand? And then this gives me a figure of 0.168 grams. So these are the mass. This is the mass I'm supposed to use. So in this case, I will say that 0.002, yes, I'm now substituting here, is equal to the mass, which is 0.1683, yes, then divide by the molar mass, M carbonate. M carbonate. So M carbonate, because we don't know M what is M, but we know what is a carbonate, isn't it? Yes, we can find out what is a carbonate. So now this we can find out by this goes here, because if I want to find this, so it means that M carbonate is going to be equal to 0.683, yes, divided by 0.002, which gives me 84.1. Yes, so now if I get 84.1, then automatically I'm gonna say M carbonate is equal to 84.1. But now I need to find out what is M plus 12 plus 16, which is oxygen times 3, is equal to 84.1. So now, since I've got that, now I'm able to find out what is M. So M is going to be equal to, when you add this, is 48. This is 48 plus 2 is 60. So it's going to be M, then the 60 goes the other side. 84.1 minus 60. So M is going to be equal to 24.1. So I have to go to the periodic table and find out what is 24. What is 24? I have to come here to the periodic table, then I find out which element has 24 as the molar mass, which is here, and the answer is magnesium. So M is equal to magnesium. So that could be the answer, and that's how the 8 marks got or came from. So it came all along from there. 1, 2, 3. Yes, that's how we got, or that's how we were supposed to get that